Welcome to this introduction to Arduino programming. I will assume that you currently have zero experience with programming, so if you've used Arduinos before, you might want to skip this one. To get started, go to create.arduino.cc and select Web Editor. Register a new account or log in if you already have one. You might have to do some additional steps to install some software. I've put a link to a full guide in the description. You'll see the screen. This is the editor. It helpfully provides us with a minimum for a valid Arduino program, a setup and a loop function. These functions are blocks of instructions telling the Arduino what to do. The setup function runs only once, when the Arduino powers up. It executes the instructions in between its curly brackets. When the setup function is completed, the Arduino moves on to the loop function. It will keep performing the instructions in that function over and over again. Arduino Unos have a light you can control, this little LED. Let's play with it for a bit. The LED is connected to pin 13, so to turn it on we have to tell the Arduino to power that pin. We do that by marking the pin as an output, and then writing high value to it. That pin will then be on until we tell the Arduino to turn it off again. Since we only have to do it once, we'll put this in the setup function. Now we can run the program and voila, the LED turns on. Our next step is making the LED blink. To do this, we need to repeatedly turn pin 13 on and off again, so we're moving the turning on code to the repeating part, the loop function. We also add a turning off part. It's the same as turning on, except we write low. Marking the pin as an output still only needs to happen once, so we'll leave that in the setup function. When we run this program, it will technically do what we want. It will blink the LED, but way too fast. It's turning on and off many thousands of times per second. Since it's on half the time and off half the time, to the human eye it looks like the LED is just on at half brightness. Let's fix our example by telling the Arduino to wait between turning the LED on and off. A delay of a second should do it. We write 1000 because the delay function expects a number in milliseconds instead of seconds. You can check this out yourself in the documentation on the Arduino website. Now it's working as intended. The LED is blinking as we want it. Let's take this further by having the LED start off blinking rapidly and then gradually slowing it down. We could do this by repeating the digital write statements and creating a long list of instructions where the delays get bigger and bigger, but we can do better than that. We can keep track of the delay and have it increase over and over. We'll start out defining the starting value of the delay at the top of the program. To define a variable, you start by saying what the type is first. This can be text, a number, a true-false value, or even more complex structures. For now we'll use int, short for integer, which is a number that can contain a decimal point. So 5 is an example of an integer, -2 is an integer, but 4.3 is not. Next up is the name of the variable. Let's call that toggle delay. Then we use an equal sign to set the value of the variable. Let's put that at 250 milliseconds to start off with. Now instead of writing a number, we can just use the name of the variable instead. When we decide we want to have the LED blink faster or slower, we now only have to change it in one place. We can also have the Arduino change the value of toggle delay for us. If we write toggle delay equals toggle delay plus 100 at the end of the loop, after each blink the value of toggle delay will be increased with 100 and the next blink will be slower. Now that our LED is blinking slower and slower, let's build a reset functionality, so when the delay becomes more than a second it starts blinking fast again. We do that by checking the toggle delay variable. We can say it's either true or false that the toggle delay variable is bigger than 1000 milliseconds. Such a true-false value is called a boolean. So we create a boolean type variable again and give it a descriptive name, such as delay too long. Because we don't really want to keep track of a value over time, but just care about calculating a value right now, we don't need to create it outside of that loop. It will just be recreated every time the loop function runs, which is fine. Then, to set the boolean, we do a comparison with the toggle delay value. Toggle delay bigger than 1000. So that when toggle delay becomes bigger than 1000 milliseconds, the variable will be true. Now we have the check in place, but we aren't resetting the toggle delay time back to 250 milliseconds based on that value. For this to work, we have to write an if statement. If statements work like this. If the boolean value between the parentheses is true, then it will execute the block of code between the curly brackets. Otherwise, we'll just skip over it. So in our case, we'll structure the if statement like this. Between the curly brackets, we'll set the toggle delay value back to 250. Since the variable already existed before, we don't need to re-specify it's an integer here. There's one last part we need to talk about, functions. Just like the setup and the loop function, we can create our own functions. As the program grows, it will become harder to keep track of which piece is doing what, so it can help to name the pieces and structure them into functions. We can separate the toggling of the LED out in its own function, for example. We start off by defining what the function will give as a result. In our case that's nothing, so we tell it void. Then we give it a name of blink LED once, parentheses, and curly brackets. Do you see that the structure now matches the one of setup and loop exactly? The only thing we now need to do is move the digital write and delay bits from the loop function into the blink LED once function, and make sure that function is called where the code used to be in the loop function. Those are the basics you need to know to program an Arduino. There will be more videos in this series, and there are many examples you can find online to advance yourself further. See you for the next video, and until then, have fun exploring the Arduino further.